So welcome everybody to this webinar today, hosted by TWBESC Electrical Safety Consulting Inc. My name is Terry Becker. I'm the owner and CEO of the company, and you may know me from LinkedIn. You may know me from client-based work, presenting at conferences and workshops. And I'm glad you've joined us today for this CSA Z462 70E 2021 edition's Changes and Updates webinar. So background information on myself. I'm not going to review this whole sort of brief CV here, but the key is I am a voting member on the CSA Z462 Tech Committee, voting member on CSA Z463, and voting member in 1584. And I've been heavily involved in my career over the last 14 years, specifically devoted 100% to electrical safety. Again, and I'm bringing that information finally in 14 years. And with webinar technology, I just haven't had my own hosted webinar. So like I said, today is our first inaugural webinar. Thank you for joining us. Again, as I said, we will have questions at the end and possibly open up the mic here too. I'm just trying to get the lay of the land on how to host and run one of these myself. So welcome again today, and hopefully everything will go smoothly. So if for some reason I do lose the webinar signal or something goes wrong, I'll contact you all and we would reschedule. So my company, TWBESC Electrical Safety Consulting Inc., please reference my website for lots of information on what I do, and we'll highlight that briefly at the end. Now, a bit of a disclaimer. You hear or see all of these disclaimers often, all right, that I am presenting under my company, TWBESC Electrical Safety Consulting Inc., and as myself, Terry Becker, professional engineer, an NFPA, certified electrical safety compliance professional, and IEEE senior member. We accept no liability for the information provided or the interpretation. This is strictly my personal interpretation with personal comments from experience. Again, you're going to hear me talk about 70 and Z462, and I don't necessarily agree with the information that's presented or how it's being interpreted in industry. And again, you're advised to consult NFPA specifically for any official interpretation on the 2021 edition of NFPA 70E, and likewise for CSA, contact the CSA group and the published CSA Z462 2021 edition for any specific formal interpretation. Again, this is my personal interpretation, no affiliation with NFPA or a CSA group. So not all the changes will be presented today. I've highlighted some of the changes. I'm going to have to go through some of them very quickly. If you're already aware of them, great. If you're not, then you will become aware of them, or you may hear a different interpretation. So again, you can purchase copies of 70E and Z462 from NFPA and CSA group, and I've got some links here as well. Right now, NFPA changed how you purchase the standards. You cannot buy a PDF. You'd have to use their online system to get a digital copy. You can only buy a hard copy of NFPA 70E, but Z462 is available in hard copy and PDF, again, from NFPA and CSA. And I do encourage you that you do buy these standards. You need to have them in your possession if you are using them within your company and as part of your electrical safety program. If we've got engineers online that are, doing arc flash hazard incident analysis studies, I'd encourage you to buy copies as well. And the reason I say that is a lot of the reports issued have conflicting information, misinformation on interpretation of 70 and Z462 that's historical and that still continues when I do review actual reports for clients. All right, so our agenda is pretty, like I should have made this webinar hours long, but it's your standard 1 hour webinar. I'm going to present for 45 minutes. I'm going to go through some of the material very quickly. And then the outcome of this webinar might be, and probably will be, other webinars to delve into some of this information in more detail, or part 2 of this webinar, where again, I have to move through this material very quickly to communicate it to you and get you, some, again, updated or different information that you may not have received in the past. So introduction to 70 and Z462. I'm also injecting a little bit of a chat here, or awareness about electric shock and sequela. This is a long-term effect of shocks that has had really no attention. Technical harmonization, we're seeing some divergence now. We were trying to say harmonized, so we'll discuss that. Interpretation and application quickly, highlighting some of the 70E changes and updates, and then the same thing for Z462 and sort of cross-correlating them as I go through that material. And then IEEE 1584, key changes, well, they're actually significant changes in the new formulas that have published now 2 years ago. And again, I'm concerned there that we're maybe getting some conservative interpretation of 1584. And again, the parameter selection that's now new is maybe not being, again, selected appropriately, again, or conservatively, and we'll highlight that. Arc flash PP evolution. And then just to bring the webinar to a close, like I said, a lot of material here. So 70E, again, it's published 1979. It's evolved significantly since its initial inception. It really related to the NEC quite a bit and more on safe installations and trying to focus on shock. And then the arc flash hazard was identified, and 70E evolved in its 2004 edition, and it had a title change. And then since the 2004 edition, we've seen significant change every 3 years for 70E. And then when we first published Z462, we aligned ourselves with the 2009 edition, and then 5 editions of Z462 now aligned with 70E. We tried to stay harmonized. In the last couple editions, some divergence, and then in my opinion, some significant technical divergence from Z462 to 70E in the 2021 editions, which we'll cover off. Right. So the good news is that the technical content in the 2021 edition of 70E slowed down. It's more organizational and structural content and movement between articles 105, 110, 120, and 130. And likewise with Z462 with clause 4 and clause 41, 42, 43. So not a lot of technical change, but the content flow, and I don't call that technical, it's sort of the structural change and how 70E and Z462 advise an end user that would have an electrical safety program, right? You know, that this is what you should have in place. And that's where content was moved from in 70E's side, article 120 and 130 to 110, so that when you read the standard, you start at the beginning and it now frames that this is how you should use this standard, and it does clarify it significantly. All right, so again, slowing down on the technical side, a lot of cleanup and reorganizational changes. Now, we're already moving into the next cycle, by the way, right? So for 70E, the public input closed June 1st this year already, right? So if you weren't aware of it, the cycles of these standards start immediately after publishing. So if you didn't know this, you can't actually submit any changes to 70E. The public input closed again, and it's into a tech committee review starting next month, right? So we're into the cycle of 70E and Z462. The next cycle is already active. We already had a planning meeting for Z462, our tech committee meeting, to launch our next 6th edition. All right, so the background here between these two standards is way back when I first got into this, when I was still working in the oil and gas industry and trying to find out, more about 70E. CSA signed an MOU with NFPA to harmonize standards for North America. And then the rest is history as we moved through that. We constituted the Z462 Tech Committee in 05, I think it was, and started in 06. And we officially published in December 2008. But Z462 is really the 08 editions aligned with the 09 edition of 70E. All right, so again, it's moved through 5 editions. We did take some divergence in the annexes right away, basically. So we have annexes in Z462 that are not in 70E, and we added some new annexes that are not in 70E related to high voltage electrical equipment, right? And that's good news because we want to make sure that users understand that 70E and Z462 apply to both low voltage and high voltage enclosed electrical equipment. And there is some information, and it can be applied actually to high voltage outdoor substations as well, but really doesn't apply to transmission and distribution. So again, Z462, 5 editions, significant changes. Again, this time around, we added some new annexes that are not in 70E. NFPA added an annex on capacitors that we don't have in Z462, right? So the annexes is where there's a real difference, a significant difference in quote, the technical content. And in my opinion, if you had 70 and Z462 and use both, you'd have the best of both standards with this divergence that's occurred in the annexes specifically. And then I'm going to present that Z462, we made some changes to the arc flash PP category table method that aren't in 70E. And that is also a significant technical change. And we also added a alternate arc flash PP category table. Again, there's a whole story there that I don't have enough time to get into, but we have two actual arc flash PP category tables for AC electrical equipment in Z462, and 70E only will have the original AC equipment table in the arc flash PP category method. All right, so Sequela just briefly, and I need you to spend some time and get into my posts on LinkedIn. I've been working closely with John Knoll, a journal electrician from Edmonton, Alberta, Canada. He has sequelae. He has multiple long-term effects of being shocked. This is not known. There's not a lot of information, or well, there is information, believe it or not, the University of Chicago Electrical Trauma Rehabilitation Institute has a lot of research into shock, but no one knows about that. In the US, you may not know about that. In Canada, we've got the St. John's Rehab at the Sunnybrook facility that's been around a while. And I've known about the electrical injury program at Sunnybrook, right, for probably a decade, but I neglected talking about Sequela, and I'm not going to neglect it anymore. In fact, again, this would be another webinar topic, is to, and I've actually talked to John, and probably will have a webinar host where I get John online here and we talk about his experience as a journeyman electrician and multiple shocks and Sequela. So just a brief, so you know, you need to look into this, go on to LinkedIn. I've got multiple posts. John Knoll, I've got an article on my website as well. I've got a second article that just published part 2 on this topic of Sequela. So FYI, we need to talk about shock actually more than we're talking about arc flash. And that's another shift, and it's a long time shift. I've been telling and talking and educating around 2 hazards, and the electric shock hazard actually needs a higher priority than the arc flash hazard. But arc flash has overwhelmed industry, right? There's lots of myths and misinformation. Again, that would be another webinar that I can highlight that as well. So just a quick montage of the 5 changes, or the 5 additions of Z462 to 70E. Initially, again, 70E and Z462 are hazard PP based, and now they're hazard identification and risk assessment based, and that continues to evolve in the latest edition. And there's a lack of understanding on the risk assessment procedure, and I think a lot of companies that have electrical safety programs do not have an electrical hazard risk assessment matrix, do not do work task based qualitative risk assessments, and again, that's another gap. But the standards are job, and then discrete work task based and risk assessment based. So interpretation and application, again, these standards are not adopted into H&S regulations in Canada, the US. They're industry accepted best practices. They allow an employer that has workers exposed to arc flash and shock hazards to demonstrate significant due diligence. But the key is, and it's bolded and underlined, the employer needs an electrical safety program. Whether it's the end user only the equipment, there's still not programs out there. Specifically, electrical contractors lack electrical safety programs or lack compliant electrical safety programs. This key is this program. And again, with the realignment of 70E now, it puts more focus on this program. When it starts, and it changed again, the content was moved from Article 120 and 130 to 110. And the same thing for Z462, where content was moved from Clause 4.2 and specifically Clause 4.3 or Article 130, right to the beginning, that, you know, as an owner of the electrical equipment with the workers exposed, it's quite clear what these 2 standards are telling you to do. And if you're an electrical contractor, it would be the same thing, right? So this is a document meant for the employers that have workers exposed, and it's work task based and risk assessment based. All right. So jobs are assigned to workers planned to reactive, discrete work tasks are identified, electrical hazard identification and risk assessments required. Now I'm going to talk about 1584 briefly again. And like I said, the timeline here is I'm probably already running over, but there's been problems historically with the IEEE 1584 and its application and the reports issued by PNs or PEs in the US. There is no correlation between hazard risk category, arc flash PP category, level letter, level number that should be included in engineer's report. There never was a correlation, and it's actually taken industry down a rabbit hole. And even, you know, the electricians and other task qualified workers, we do not call arc flash PP by a category and HRC number. We call up arc flash PP with an arc thermal performance value in calories per centimeter squared. That's what the worker needs to know. We shouldn't be talking about categories when we have IEEE 1584 arc flash hazard calculations completed. We need to continue to work on this. This needs to be fixed. So what we did in 70E and Z462 is we added tables after where it mentions determining additional protective measures and 2 methods, that when you have incident energy analysis, you have 2 ARC rated levels, not categories, not level letters, but this is still a problem. I still see this in engineers' reports that I issue on that are issued to me and I review on behalf of clients when I'm helping them develop electrical safety programs. And I flag it to the engineer under code of ethics. I have a meeting with the engineer and try to educate them. And there's some challenges here. So this is an ongoing project that I'll probably be working on forever to get us off of these categories or level letters, and when there's an incident energy analysis study completed. And we do not want to report it out. And it relates to the 40 cal myth as well. Historically, again, that was embedded in the power system software, and the engineer just accepted that greater than 40 cals was dangerous and no PP exists. That was all incorrect. And I'm still seeing some issues there. So here's the quick excerpts of the 2 tables. Again, from 70 and Z462, when you have incident energy analysis, select clothing with an ARC thermal performance value. The labels as well are a problem. These are compliant labels. We actually have an annex in Z462 Annex Q that I wrote that's not in 70E, and the intent was to try and clarify what a compliant arc flash and shock equipment label should look like. And it should be ANSI Z535 based, right? This is what the label should look like. These are compliant labels. The one on the bottom, that's sort of the latest derivation. I've just increased the size of the incident energy value and the size of the voltage on the label that you see on the top left, because these labels print out 4x6 and the print's very small. And we want the qualified electrical worker, the task qualified worker, to focus in on that incident energy value and focus in on the voltage for shock. And then they determine arc flash PPE with an arc rating, right? An arc thermal performance value that's equal to or greater than the incident energy on the label, not a category number, an ATPV on the label of the PPE. And then, yes, some of the labels have HRC on it, and they shouldn't. The PP shouldn't have HRC2 on it. It should only be an arc thermal performance value that the worker's trained to look for. And then when the arc flash PP category method is used, they know that the arc flash PP category 2 is min 8 calories, or arc flash PP category 4 is min 40 calories. And here's a new technical change for you in Z462. We have an arc flash PP category 5 now that's not in 70E, that's min 75 calories, but only if you use the arc flash PP category and only related to the low voltage switchgear electrical equipment row. So again, labels out there are still, and there's literally hundreds of thousands, if not millions of labels installed across North America. And from my review of these labels with clients, I'd say 50 to 75% of them are not compliant labels and do not provide the right information to the qualified electrical worker or the task qualified worker. The bottom of that label is where there's also a gap. The information on the bottom of the label should be clear with respect to where the incident energy applies and related to the electrical protected device that the incident energy was calculated based on, load, line, side, bus of that protected device. And I find on a lot of labels that is not clear. The other option too, other than labels, and I'm starting to encourage this with large clients that have the right staff to manage this, is to go with a generic label and point to the results table, right? So you could replace all of your arc flash and shock labels for one more time, huge cost again, but only one more time with this generic label, and then take the results tables from the engineer's report, put them into a spreadsheet or a table, and then issue that table in a PDF to your staff electricians, your contractors proactively, post it, laminate it in electrical rooms, so hard copy PDFs. And really, to me, this is for large, again, industrial, commercial, institutional sites with appropriate staff to manage this, how we should give the information to the workers that are exposed. So again, FYI, this is now allowed. It was allowed in the last edition of 70E and Z462. Now, again, I'm already starting to talk about some of the changes and updates and framing it. And I'm just going to go through these slides. I'm just going to move through this very quickly, again, to frame some of the things that I've talked about. Remember, not a lot of technical change, more what I'll call organizational change on how these standards are structured and presented to the user, again, the employer that has workers that are exposed, right? And in my opinion, it's awesome what happened. It made a lot of sense with what was moved around in both 70E and Z462. And for the most part, that reorganization is almost 100% harmonized between Z462 and 70E. There's a couple subtle differences. Normal operating condition, we changed it in Z462 to normal equipment condition, and we moved that content from clause 4.3 or article 130, to article 110 or clause 4.1, but we put that, and there's 6 of these conditions, under the risk assessment procedure. In 70E, it's not under the risk assessment procedure. It's part of the preamble, right, related to, again, what the employer should do. And in my opinion, 70E should move that, and we might see that in the 2024 edition, under the risk assessment procedure, because normal equipment conditions need to be evaluated as part of the risk assessment procedure. And in real time, right, validated by the qualified electrical worker or the task qualified worker that's exposed. So I'm just going to highlight some of the definitions here. And again, not get into much detail, but balaclava, barrier, electrically safe work condition. Again, some minor wording changes really. The arc resistant equipment definition sort of realigned the wording there. And this is reflected in the work task tables under arc flash risk assessment, table 130.5. I always get this mixed up. G, or was it? No, C, sorry. And table 2 in Z462. So some subtle changes in the definitions, but you can see there's not much here, right? There's not much here at all. So field evaluation, shock hazard, some wording changes. Voltage nominal, it added some language around 48 volts DC and float voltage and 60 volt DC. And I've noted it's an NEC correlation based on my review of that when I did take a look at it. And then some minor wording changes to working on, but not significant changes to the definitions or additions. Again, this is where the key changes occurred, is the changes bringing forward content from Article 120 and Article 130 and putting it into Article 110. And if you really understand what these standards are doing, and I hope that if you're continuing again to use 70, that you'll look at this and go, this makes a lot more sense now, that this is methodically what should happen with the user using this document, right? That we've got the priority to eliminate exposure, some general requirements, and an elimination, establish an electrically safe work condition. Not the detailed procedure, that's still in Article 120, but it's basically saying priorities to eliminate exposure. If you establish an electrically safe work condition, if you can't establish an electrically safe work condition, we need energized work to be justified, and then it gets into the electrical safety program requirement, right? So this is significant as far as reorganizational and structural content. That is amazing to me, because now there's no doubt when you read this, it shouldn't be on priorities to eliminate, justify energized work. That was moved forward from Article 130, right? Or Z462 clause 4.3, because it was by the permit. And it didn't make any sense to have it with the permit, because the permit is a separate topic, right? So, but ultimately now when you read this, and I encourage you, if you don't have a copy of 70 or Z462, that you buy a copy. I'm just providing, again, some interpretation, some excerpts. That's it. You need to see and read this content. It is significant, and it does clarify the application of these standards. Now, again, the intent is that we want this whole thing to be about eliminating exposure, and it's the first hierarchy of risk control method of the 6 hierarchies that are listed in 70 and Z462, but then 70 and Z462 allow energized work. I get comments, well, we can't work energized, it's against the law. And I said, well, no, it's not against the law. And 70E and Z462 allow it, but there's a methodical process that you have to follow. And I frame it under what I call an energized electrical job workflow, right? So I've got this energized electrical job workflow. And again, when I'm on Zoom with my background, you can't see it 100%, but this workflow is how I frame this when I talk about it with users, right? And so the first thing to assess is, can we eliminate exposure? If we can't, then the worker gets a work order, planned or reactive work, and it's energized work tasks. And then they move forward with that there is justification, and the permits get dealt with. In most cases, the permit's exempted for, again, testing and diagnostics work. In my opinion, the permit could have additional exemptions added in an employer's electrical safety program, right? So structurally, again, I really like what happened here for the flow of 70 and Z462. I've highlighted in yellow that we just have 2 different words now. 70E maintained normal operating conditions, and Z462, we now call it normal equipment conditions, and put it under the risk assessment procedure. So again, just I'm not going to read this all out directly. I'm going to paraphrase what's going on here, but again, realignment, some wording changes. The other big change was Article 110.5 I1, and it's this figure. So there's now a checklist or a figure added, I2, that gives you an example of a job safety planning checklist. But in Z462, we have a totally different example, which is fine because they're just examples and they're in the annexes, so they're non-mandatory. And I actually have a very unique energized electrical job safety planning form. Again, you won't be able to see it entirely, but there's a bit of an excerpt of it, right, that I provide clients when I work with them. And I've had that job safety planning form for, I don't know, a decade. I always knew we needed field documentation. The job safety planning form is mandatory, and now there's an example. Some comments about lockout tagout, that the lockout tagout program could be part of your electrical safety program. I don't recommend that. It never should be. The lockout tagout program should be separate, related to your occupational health and safety management system. Again, this is subtle changes. The user needs to use these standards, interpret them, and apply them. And I'm telling you that that's fine. And that companies will interpret this differently. That's also fine. Due diligence is at the onus of the user, right? The client that's using this, the company that's using this. But again, it's the interpretation that I'm saying is not necessarily correct or could be conservative. The training piece, Article 110.16, the most significant thing is it recognizes classroom training can include interactive, electronic, or web-based training components. So interesting enough, with COVID, there was no other choice, right? And all along, I've advocated e-learning or online learning, with this type of platform. So ironically, with COVID, and by the way, I hope everybody is doing well with COVID and moving through that. Again, in North America, or if you're internationally joining this webinar, I hope that you and your family and everybody in your workplace and your country is moving through that and dealing with it. So again, this was cool because with COVID, we had no other choice. All right, so test instruments, just some minor wording changes here, eliminating the 50 volts and just saying where an electrical hazard exists, adding the word wet locations for the use of a GFCI with portable cord and plug connected electrical equipment. And just equipment shall be used in accordance with the manufacturer's instructions was a new text added to Article 110.12. And this one is now we're moving into Article 120. So again, I'm just highlighting again the key changes. Like I said, there really wasn't a lot of technical changes. It was more of this huge structural movement of content, and really, it's amazing. If you really read it and you get it, you're going to say this now makes more sense than it ever did before when I review Article 110 or Clause 4.1 in Z462. So this relates to adding some languages about, that a lockout device can be only a lock without a tag, but you have to have this information in place. So these are new items, just again, little tweaks here and there. This one's unique. The locks have been provided without a tag, but then the lock has to have some unique identification on it. And it lists 3 other requirements here when that's the case. Elements of control. So establishing electrically safe work condition, 120.4, stored energy. So a new note was added that correlates to this new Article 360 related to capacitors. So 70E, the biggest technical change was a ton of information on capacitors that was brought forward from research in one of the labs in the US and from a paper presented at the IEEE Electrical Safety Workshop. By the way, the IEEE Electrical Safety Workshop's in Jacksonville next year, and it's going to be in person, and I'm looking forward to attending. And hopefully, if you're there, we can connect if we haven't already. So IEEE ESW next year is in person in Jacksonville. So this paper was then taken from ESW and put in as a proposal into 70E. It was huge. So capacitors, tons of information that was really needed. So we keep learning, and then we keep adding to the body of knowledge in 70E and Z462, but we don't have this annex in Z462 right now, right? So again, that's where both standards, I would buy both, and then you have all of the information that's beneficial from both that may not ever arrive or be included in both. I don't think we're going to get 100% content harmonization or technical harmonization in 70 and Z462. So again, the capacitor content is significant. So just some wording changes in the actual 8-step procedure for establishing electrically safe work condition. So some wording changes again in step 5, block or relieve stored non-electrical energy in devices to the extent the circuit parts cannot be unintentionally energized by those devices. So subtle wording changes, same overall context for establishing electrically safe work condition. Some wording changes here, verifying the energization to test for absence of voltage, the correct sort of technical words. And then specifically, this is from the public review comment, to further clarify again this automatic voltage tester, right, in the language. So absence of voltage tester, not a test device. Again, testing for absence of voltage, testing for absence of voltage, not verifying. So the automatic voltage testers, specifically the product from Panduit that came to the market early, and there's another product from iGuard in Canada versus the products from Grace Technologies. So one is, again, automatic, one is manual and requires, again, the qualified electrical worker to do a test, as you can see in the picture. So this language continues to evolve to further clarify in 70E that these automatic testers can be used. In Z462, we say that they're still an alternate, that they're not and cannot be used exclusively. So there's a technical change or a content change that's unique. 70E says you can use these. You can use these if you want independently of any test instrument, and 70 in Z462, we did not and still do not have that language. All right, so watch these subtle language changes, words and terms and phrases that happen, every 3 years, very typical, and a lot of global wording changes. So Article 130, again, moving content to Article 110, the same thing for Z462, but some introductory text was added to, because a whole bunch of information disappeared and there was a gap. So what was added was language to introduce Article 130, and the same thing for Clause 4.3 and Z462, right? So some general introductory language, because we took a whole bunch of stuff and moved it from Article 130 to 110, or from Clause 4.3 to Clause 4.1. All right, so revise the wording, clarify intent, use of Article 130, right? So work practice and safeguarding employees when we can't establish an electrically safe work condition. One other thing I haven't mentioned, the other divergence here too, is Z462, the low end thresholds of application. 70 is still a 50 volt standard based on OSHA historically, but we technically deviate in Z462 that we have 30 volts AC, and now we added and upped the voltage to 60 volts DC as the low end thresholds, where the standard really doesn't apply and you don't need a permit. So there's a technical deviation, 50 volts threshold in 70E, 30 volts AC or 60 volts DC in Z462. All right, so back to Article 130. And again, it basically implies that once we can't establish an electrically safe work condition, that with the requirements of 130 are, performed by a qualified person, that you may need the permit, because the permit's still there. There really wasn't any big changes to the permit requirement. And then this qualified person has to complete a shock risk assessment and an arc flash risk assessment themselves, right? And then that's where the risk assessment procedure, I think, has some confusion. The risk assessment procedure is performed by the employer's electrical safety committee, and then we have the worker doing their individual arc flash and shock risk assessments. So in Table 130.5C or Z462 Table 2, this was added as a new work task. And it's, again, opening a circuit breaker switch the first time after installation or completion of work or maintenance in the equipment. And then the condition of maintenance is any, and the likelihood is yes. So greenfield, brand new, commissioning contractor, they should wear arc flash PPE when they open or close that circuit breaker for the first time in commissioning or after significant maintenance. Power circuit breakers are removed every 3 to 5 years, and significant testing is completed and other maintenance on that circuit breaker. Rack it back in the first time you close it or open it. This would then imply arc flash PPs needs to be worn. Now, I'm advocating that once we get it back to normal operating condition or normal equipment condition to operate, we do not need arc flash PP. Huge controversy, probably not going to go away, but this work task is independent of the other work task that says operating a circuit breaker, disconnect switch, contactor, or motor starter, which allows you, again, to make the decision based on normal or abnormal conditions, which is, in my opinion, how this should be managed for normal operation of electrical equipment. All right, so incident energy analysis method, again, it doesn't have to be great. Add a clarify outerwear that's worn over it. So if you wear something over top, like it's cold outside and you wear an arc rated jacket over top of your arc rated clothing underneath coveralls, that's fine. It just has to be arc rated, but it doesn't add to the actual arc rating. The actual arc rating would be the coveralls underneath, not the jacket that's arc rated worn over top. Let's see, work involving electrical hazards, new note added to provide guidance on so this is where the incident energy is greater than available arc flash PPE, and it's only for absence of voltage testing that it lists again some steps that you can do to reduce risk, only for absence of voltage testing, again, where the incident energy is greater than the available arc flash PPE you have, so non-contact proximity tester, observe visible disconnect, increase the working distance, consider system design options. So unfortunately, item 4 would be a more proactive approach where the incident energy is greater than arc flash PP available. So I've promoted a higher AT arc flash suit for quite some time. You can get a 140 cal arc flash suit from Oberon Company, a 100 cal suit from Oberon, and other vendors are moving to providing higher ATV arc flash suits. There's a balance between engineering, incident energy reduction, and arc flash PP. So what was also added was a table that gave you the voltage class ratings of rubber insulating gloves taken out of ASTM standards because it was never there. So this table's been added in both Z462 and 70E. Chapter 2, really no significant changes. The same thing for Z462, some rework in Z462 of our clause 5, but I'm not going to review any of that in detail. And then chapter 3, the big thing is this actually batteries, this was big too, is in Annex F, a battery risk assessment flowchart has been added, but the big thing is the capacitors added in Article 360. So this battery assessment flowchart is in Annex F. It's not in Z462 in our Annex F, another annex change. But again, gives you more information on when you look at batteries. And again, we're going to see, I think, a lot more of this come with large storage battery systems going in, but even UPS battery systems. This was actually in the handbook for 70E and probably pulled from the handbook and brought forward into the annex of 70E. So again, the capacitor annex, significant information. Encourage you, if you don't have a copy of 70E, the new edition, buy it just even for this annex. All right, significant information. And again, the annexes were cleaned up in 70E. We do have some divergence again and some new annexes in Z462. So I'm going to accelerate here a little bit. So again, Z462, the conversation is the same. It's just instead of article, it's clause. So the changes that I've told you about are the same. I'm just going to point out a few different things that we did differently. So we do align with the organizational changes from 70. This is where we do match the organizational changes. But again, now we're talking clause numbers. So again, the policy statement to eliminate, establish an electrically safe work condition. If you can't, right, then, justification for energized electrical work. All right. And then it moves into the electrical safety program clause, and the clause numbers have renumbered to accommodate this. So you got to realize the clause numbers here will change for some of the clauses in clause 4.1 and some of the clauses and articles in Article 130 or clause 4.3. So you just have to, if you were quoting a clause number before, it may be different now in the areas where the structural change occurred, right? And then one of the things I said is we kept the word, changed it to normal equipment condition instead of normal operating condition, but we put the 6 items under risk assessment where, in my opinion, it should be. In 70E, it's floating outside of the risk assessment procedure. Same thing on training, like I said, we added the same task in Z462, it's table 2. So that's again harmonized with 70E. I think there was some subtle changes to some of the other work tasks. I think we might have deleted one. And then the arc resistant electrical equipment, that description was changed subtly. So, but it wasn't new. It was just subtle changes. So again, this is where we deviate. This is where the divergence is in Z462 is the arc flash PP category method in clause 4.3 or Article 130. We had the luxury of using the new IEEE 1584 formulas, and we had a working group redo the calculations using the parameters listed. And for low voltage switchgear, using these parameters, 35 KA and 30 cycles, maximum available fault clearing time, it yields a far higher value than 40 calories. I think the number was 73 calories. So we created arc flash PP category 5, added that to our table 6C, right? None of this is in 70E. And now there's a new category 5, minimum 75 calories, right? So this is a huge, significant technical divergence. And I don't know if it's going to be in 70E in the 2004 edition. I guess time will tell that story. If some public comments came forward to revalidate the incident energy values underneath the arc flash PP category tail method. So this is in Z462, that if you don't have an engineering study, you have the tables, and you have low voltage switchgear, you're going to have a 75 cal arc flash suit So again, we reviewed the changes, created a new alternate. So when we were reviewing it, someone said, why don't we create a new table that's easier for the electrician to use? They don't have to have any fault calculations. They just look up the nameplate data. I like the idea, but I totally disagreed with the table when we added 240 volt single phase electrical equipment, right? So I do not support this. There is no IEEE 1584 substantiation. 1584 applies to 28 volt three phase. There is a note, but it's clear that 1584 does not apply to single phase electrical equipment, right? So this is again a technical deviation. This is actually a table that's embedded in annex in Z462, but it is normative. So in the actual clause content, it says that you can use either of these tables, right? So it's a user decision, and only table 6A is embedded in the core body of the clause. This is just a short excerpt where the 240 volt was added. I totally disagree with all of this. The other information that's here for 28 volt or higher would be valid, but sustaining an abnormal arcing fault at 240 volt single phase has not been substantiated in 1584. And it may be later, it may be the next phase in 1584's research, which I believe it is based on my involvement. And then what I've got is, this is the DOE in the US, their sort of user group. It's a public website. So they have a publicly available paper that they published that they looked at 240 volt single phase. They say that you can't sustain an abnormal arcing fault at 240 volt single phase. So this is going to be hugely controversial. And it is in Z462. This is not in 70E. And as we move through this over the next year or two, I think this is going to be significant. And technically, it means that every household has a panel board in it where an abnormal arcing fault could be sustained. So that's what also concerns me, right? But right now, I do not support that 240 volt single phase can sustain an abnormal arcing fault. Now, the annexes in Z462, this is again where we clean things up. And what happened too is CSA adopted ISO 45001. So we rewrote Annex A, and it's an amazing annex correlating how Z462 can be applied against an occupational health and safety management system, and ultimately to build an electrical safety program. Again, all the old formulas have been deleted from both 70 and Z462, and there's just some introductory text to reference the new 2018 edition. Appropriately get rid of the formulas. Go check out the formulas in the actual IEEE 1584. The new job planning checklist was added. Z462 Annex K, we actually adopted some new language in there around arc blast pressure that's not in 70E 2021 edition. So this is another great thing that we did, because arc blast pressure has been miscommunicated for a decade, right? So we added language in to clarify that arc blast pressure is not dangerous. It's not high, right? It's not going to be high. That there's been some papers presented and some additional information that the arc blast pressure is not what it was made out to be. And again, talk about that more offline. So here's the annexes we added for high voltage: Annex P, electrical switching and isolation, and Annex T, temporary protected grounding, and then that new Annex V for the second alternate arc flash PP category table that was meant to be easier for a qualified person to use. But again, I don't like the 240 volt single phase inclusion, and I don't support it. That's my personal technical interpretation. All right, so again, I've noted that, and the 240 volt single phase arcing fault sustainable is not substantiated in 1584. It's not in any other papers that I've come across, and I tried to research it. So again, I don't support that portion of this alternate table. And currently, until I get better information, I would not support that 240 volt single phase can sustain an abnormal arcing fault and become an arc flash. The new 1584, again, I'm looking at the time, and I'm always running short when I talk, but the key here is we need quality engineering reports. And right now, a lot of engineers do not know that IEEE 1584.1 exists. And 1584.1 is an amazing document. Published in 2013, it's been around a while. We're currently rewriting it slightly to update it, but there's significant problems still with these reports and interpretation of the results, and even the reports being a quality report as well. So new formulas, you need to be careful here if you're an engineer interpreting them for your client. If you're the owner, you need to control the consultant as best possible. And I recommend you do that with a technical specification. Not a lot of technical specifications have been issued by owners of electrical equipment. So the engineering consulting firm proceeds. And again, I've seen reports where there's been no substantiation of these parameters and the selection and the impact on incident energy. So again, that table is my interpretation of the impact. The biggest impact is the box electrode configuration and if HCB is selected. So cross-correlating the changes between the box electrode configurations again, and what was added was the VCBB and the HCB, right? And again, the new formulas, and the biggest impact in the new formulas is when HCB might be used. I've added and provided, and this might be another webinar, it probably is, where I'll go through this in more detail on my interpretation and my opinion, again, of the different parameters and the impacts they'll have and where they should be applied. In this case, the box electrode configuration. And I have a table where I make recommendations. And ultimately, this should be part of an employer's electrical safety program, that the technical specification is linked to it, because these studies, they provide the hazard information, and the information is put on a label, right? So it's really, the label should be controlled by the electrical safety program. And again, the owner of the electrical equipment should have a technical spec to control the consultant, but the consultant should also work with the client if there's no spec to educate them, but don't be too conservative, right? You need to be realistic in interpreting 1584. And again, the labels that I mentioned earlier, right? So lots of misinformation about the 40 cal myth out there and blast pressure, right? Again, I'm just briefly highlighting that again, as I will continue to do for a long, long time, that arc blast pressure does not correlate to incident energy. It never did. And Dr. Ralph Lee, his research from the late 1980s actually emphasized that, all right? So again, this is his graph from one of his research papers. This is actually published in the IEEE Yellow Book, which is now the 3007.1, 2, and 3 series. So this is actually published, right? And I pointed people, I said, this is published in an IEEE standard, the Yellow Book, that incident energy doesn't correlate, right, to arc blast pressure. It correlates to arcing fault current, right? So it never correlated. So 40 calories is not a dangerous incident energy level, and it's false statement that no PP exists, because again, Oberon company has an arc flash suit up to 140 cal ATPV. All right, so there's no correlation. We need to continue to work that out and ensure engineers' reports don't include any information about this. And the reports, again, don't include a HRC number, a category number, a level letter. There's no correlation between, again, the arc flash PP category table method and incident energy calculations. And I need to continue to make sure that the software that's used out there doesn't continue to exacerbate this problem, all right? Arc flash PP evolution, just quickly, again, I'm running short on time. True color gray lens technology, significant. And I recommend that companies upgrade their arc rated face shields and their arc flash suits to true color gray. It's a significant change. You can see from the pictures on the screen. It has a positive impact on risk, meaning the life of occurrence is driven down when you move to this true color gray lens technology. And you can see the faces of the workers. So this is me on the right and Cindy on the left. You can see our faces through that shield, and the LEDs on the arc rated face shields. You can see that it's lighting up that MCC starter bucket, and you can move it with your head. So the LEDs, again, the hood ventilation system, still I find arc flash suits with no hood ventilation systems. You got to get the hood ventilation system. And as I mentioned, the ATPV of arc flash suits, there's probably 6 or 7 or 8 vendors now that have 75 to 80, but only Oberon company still has 100 and 140 cal. And again, you can assess using this PP, using risk assessment, and it's valid. It's valid. And we need a balance between engineering incident energy reduction methods and PP. And you can see the face of the worker here again on the arc rated face shield on both of these pictures and images, right? And again, on the right, you see the latest 140 cal suit from Oberon with the true color gray lens technology and the LED lamp. All right. The hood ventilation systems, I've seen the one on the left so many times out there when I do external electrical safety audits, and it's a simple battery pack and the wiring and a micro switch, and half the time the wiring's broken, the switch doesn't work. It's not industrial commercial design, it's a retrofit. The Oberon hood ventilation system was custom designed with a tubing system that brings the air to the front of the hood. No other manufacturer has that ability to bring fresh air to the front inside the hood while the worker's wearing it, right? So upgrade your PP, look at the changes. This is huge. Last year, Oberon brought out the escape strap, right? So it's embedded right in an arc flash suit. You can see the X where it's braced to be able to grab the worker from the standpoint of weight. And this escape strap is brought out. So you don't need a rescue hot stick anymore when you need 2 workers for high voltage work predominantly. You can use the escape strap. I think this is an amazing innovation from Oberon. You may not be aware of it. And again, this, in my opinion, every arc flash suit jacket should have this escape strap on it. And it also comes in a vest. right? The vest can go over top of an arc rated coverall. It's arc rated material, and then the escape strap allows you to do rescue faster. Arc Flash PP works. I've had the luxury of going to both Kinetrix and Kima, and I'm looking at the clock. We're running down on time, so I'm going to sort of accelerate here and then open up for a few Q&As. So again, Arc Flash PP works. Again, I've had the luxury, like I said, to see some videos of Arc Flash PP, and again, I'm going to defer and probably come back to this in a separate webinar. And then in this case, that's Scott Marjano with Tyndale pointing to a polyester shirt that was worn underneath and it melts. So it's important that workers have non-meltable fabric underwear, shirts, and underneath arc-rated clothing. So this is an Oberon arc-rated face shield. It's a 17 ATBV. I happened to get invited to Kinetrix when Jack Hirschman, who's the owner and the inventor of the Oberon products, was doing some testing on the 140 arc flash suit hood. And I said, Jack, can we arc flash my shield with the LED on? He said, go get it. I did. We arc flash at about 20, and you can see the LED still working. I was impressed. And that's just a Petzl LED on there. And that's what will happen to the shield. You'll see that sort of carbonization, and then the polycarbonate plastic is melted. This is just a picture of the Kinetrix lab, their actual test bays, their control room. Again, this is a video that I just don't have time to play, but again, it's the actual testing of that shield. This is what the hoods will look like if they're exposed, and that outer layer of blazing like that is what should happen on the arc flash suit hoods or the jackets. So again, to bring things to a very quick conclusion, the changes are not technical in the latest editions. It's more organizational, right? Which I like. So it's organizational rather than a lot of technical, but we have two items of significant technical divergence: the arc flash PP category 5 min 75 and the new alternate arc flash PP category table. And unfortunately, the inclusion of 240 volt single phase, which again, I don't support. There's no substantiation in 1584. So there's some divergence there. It's percentage wise, it's not significant, right? So the good news, things are settling down on the technical content changes, but the structural changes were significant in these 2021 editions, like I said, to the benefit of the client that uses it to develop an electrical safety program and clarify that. And companies need electrical safety programs, or they need compliant programs. And that's a subjective, debatable discussion as well. I see a lot of programs that are not compliant, right? And I can substantiate what one is, and that's another future webinar. Like I said, this is my inaugural webinar where I'm hosting it directly. I just wanted to use the 2021 editions to kick things off. I'm planning on having more webinars, probably every 2 months at a minimum, and different topics where I can present directly, my interpretation, my opinions, and deal with, again, in future webinars, try and have more of an open Q&A maybe throughout the webinar as well. So again, some divergence and a couple areas of concern, but the structural changes are awesome. So again, update your company's electrical safety program. Provide training on the latest editions. Every 3 years, you're supposed to retrain. So you've got to provide, again, compliant arc, flash, and shock training for your qualified electrical workers, your task qualified workers. Manage IEEE 1584 and the parameter selection in the O18 edition. And watch out for the HCV and don't be conservative. If you're the consultant, don't be conservative. If you're the end user, ask questions. Get educated. If you're attending this webinar, it's to get more information and knowledge, which is awesome. And again, I could talk about 1584 for a lot longer than I've had, today. And again, that might be a future webinar. And then do a gap analysis to arc flash and shock PP that you have and look at updates. And again, your training, your electrical safety program, you need to train your workers on your electrical safety program, roll out an orientation of your company's specific policies and practices. All right. So I'm just going to wrap things up. The sources of the information, again, NFPA and Z462, please buy these standards, right? And buy 1584 and buy 1584.1 if you're using them within your company, right? Have copies available. All right. So just to close off the webinar, again, I provide electrical safety consulting. I'm helping companies to identify the gaps and deal with them, and ultimately through an electrical safety program. So implement a compliant program, train your staff, compliant arc flash and shock training, deploy your electrical safety program. And I've been launching this year an online electrical safety program deployment option, partnering with MSM eCore. So you can take your entire electrical safety program, deploy it on an iPad or a phone. You access it from a computer as well, but it's significant when we can get forms, all the required forms, permit, job safety planning form, deploy it on a phone or an iPad to automate the paper trail automate and give the information digitally. Your program, supporting procedures, even single lines can all be deployed digitally these days with web-based occupational health and safety management system software. Right. So follow up with me on the electrical safety program topic. Book an electrical safety training session. I'm going to be moving to open training sessions. And again, if you get in touch with me, I'll talk to you about electrical safety program and compliant programs and IEEE 1584 as well. So I'm going to open up the Q&A, and I think we have a couple Q&As. So very briefly, again, I'm going to go over for a few minutes if you're still online. So again, I appreciate you joining me today. This was my first webinar, and I already know, and people that know me, Terry will talk for a long time. So I've already learned that I need to target the webinar content and give you more time to absorb what I'm presenting and more time for Q&As, right? So one of the questions says, could you please provide some insight on best practices in electrical installation on electrical safety perspective? So again, for North America, the legal requirement is the National Electrical Code, and Canada, the C Code Part 1. Safe installations is a priority. On top of that, the power system study and the engineer that performs it can proactively consider safety by design or prevention through design aspects of the power system design that will, some of it, eliminate exposure, or some of what can be engineered, reduce the incident energy. But there's a balance between engineering and the application of arc flash PPE. Money doesn't grow on trees. And in my job when I was in the oil and gas industry, if I went to my manager and said, give me 10 million and I can do this, he would go, is that the right solution? Right? So there needs to be a balance for arc flash with incident energy, potential reduction strategies engineered in, right? Technically feasible and cost-wise affordable. So you need to balance, again, engineering to arc flash PPE. It'd be nice to get to 8 calories, but technically it's not feasible. And cost-wise, again, how much money does your company have? So balance that out. It says, from what capacity do we need to put arc flash label? So it's not capacity. So the arc flash label requirement is an outcome of the IEEE 1584 incident energy analysis, right? So then you can either put that arc flash hazard information, and on the right-hand side, put the shock approach boundaries from 70 and Z462 on the label. That's pretty typical, that label format for the last 14 years I've been doing this. So again, it's doing the calculations, right? And then how do you provide that information to the qualified person? On the labels, typically what industry's done, but as I said, you got to manage the label specification and the information that's communicated on that label. All right, so we need to understand abnormal arcing fault sustainability in IEEE 1584 28 volt 3-phase, right? For DC, 125 volts DC power output of a battery, right? Or solar is 1500 volts DC. So at those DC voltages, abnormal arcing fault sustainable, and then, do a calculation or use the arc flash PP category table methods. And that's to give the hazard information to the qualified person so they can determine arc flash PPE. How do you approach PPE use if no live parts are exposed? All is fully covered with plexiglass, but doors are open. Do we still need to wear PPE if incident energy is higher than 1.2? So there's a couple questions there. So shock hazard identification is when there's exposed conductors and circuit parts and inadvertent movement risk. So if you open a hinge door of electrical equipment and it's fully guarded, fully insulated, and finger safe, there's no shock hazard because there's no inadvertent movement risk with your hands. Typically, and that was the problem, electricians went in with their hands bare like this, and they didn't have rubber insulating gloves on, because had they had rubber insulating gloves on, they wouldn't have got shocked due to inadvertent movement risk. So here's what for shock, we need rubber insulating gloves on anytime a qualified person's hand is going to go inside restricted approach. And the shock hazard goes away, right? The residual harm goes away as long as these gloves are the right class, they're stored properly, dielectrically tested every 6 months, and pre-use air and visual checked, right? So you got to go backwards a little bit on electrical hazard identification. And then what do we do, right? So if you open up a hinge door and it's fully guarded and insulated and finger safe, there's no shock hazard, but your interaction, because 70E and Z462 are work task based in table 130.5C and in table 2. So there's 31 work tasks listed. You need to take that task table and make it your own task table and change the descriptions, change it up, add voltages, because some of the tasks don't have voltages on the voltage where an abnormal arcing fault can be sustained, right? And then if the incident energy is technically less than 1.2 calories, you don't need arc rated clothing, but you would still wear, if your company has an everyday wear arc flash or shock PP clothing requirement, you still have that on. But technically 1.1, 0.7, 0.3 calories will not ignite flammable clothing, right? So your company needs to decide on a policy. Are we still going to wear minimum arc flash PP if it's less than 1.2 calories, or just our site standard PPE? All right. So that's, again, just another point of discussion. And these are things that you document in your company's electrical safety program, your interpretation of this information. So I'm running a little bit over. If you hang on, I'll answer maybe one more question. Can we rewatch the webinar? Yes. So we will be issuing a link to the webinar to those of you that have attended. So that'll be sent out. And then elaborate further on similarities and differences of permanent absence of voltage tester requirements. On a large equipment lineup, such as MCCs or switchgear, what's the best practice for electing locations of permanent absence? So again, the establishing electric safe work condition with the automatic voltage testers or the test stations, again, from the different vendors, you need to decide where you want to maybe have those. And what I see trending is that where we maybe have a non-electrical worker doing isolations, then they can check, right? We don't need an electrician. If again, you trust that automatic voltage tester, right? Then you don't need an electrician to test. If you trust it again, and then we could disconnect the low voltage motor, right? So, and then the test portal, right? The option, I think I like that actually, because the qualified electrical worker still has to use a test instrument to get a positive with their test instrument. Again, and that's wired to the load side of a disconnect switch or a circuit breaker, right? Because that's where you want to know you've got absence on that isolation device when it opens. So again, interpretation, as I said all morning here, this is the challenge, is different interpretations. Things I mentioned today, people will go, Terry, that's wrong, or I don't agree. That's okay, right? Debate is healthy, but it's interpretation and then my interpretation and what I communicate to clients that I work with electrical safety program development. So if you do install either the Grace product or the Pandu product or the iGuard product, you need to decide where it makes sense. Again, money, and where do we need it? Why do we need it there? Right. So again, I wish I had enough money and everybody out there had enough money to buy all this stuff and proactively retrofit it and proactively buy it from factory. But it's just a balancing act. And especially, the economy in Canada right now isn't that great. So, up here, US economy may be better, but even if the economy was super strong, it's just still good engineering to make decisions and balance substitution and safety by design with the need for arc flash PP when you do an arc flash risk assessment. Now, I've talked a lot about arc flash, and I want to end this webinar like shock. We need to put more focus on shock. All right. Shock, statistically, we have the incident statistics. Shocks are still happening, right? Overhead power line related shocks and electrocutions are still a significant statistic in North America and globally. And then for low voltage work, non-electrical workers, qualified persons, there's still shocks occurring. And for qualified persons, we need these rubber insulating gloves with leather protectors worn every time, all the time, when your hands go inside that restricted approach boundary. We can get rid of shock, but the attention needs to shift from arc flash to shock and balance both hazards out. Give them equal attention, not all this topic on arc flash, and the myths and information on arc flash are propagating still around me, right? So again, I probably won't provide the slides, but there will just be probably the video recording. Again, this is copyright material to my company as far as the presentation and the information presented. Again, so I probably won't issue the slides, but again, we'll probably have a digital link provided. So in the interest of time, I'm noticing that I'm over by 5 minutes. I'm only 5 minutes over. And if you know me, you're going, Terry's actually stopping early. So again, this is my first webinar. And again, I really appreciate those of you that attended. And again, this is a test. This was an experiment. We were even trying to sort of Zoom here the last minute this morning. I think this Zoom webinar works great. We still have a few things that we'll sort out. And again, I appreciate everybody attending. If you do have any questions that I've stimulated, get in touch with me offline, right? My email address, my phone number. I'm on LinkedIn. I'm trying again to do as much as I can on LinkedIn and balancing everything out. I am working with John Knoll on LinkedIn, on Sequela. So search John Knoll on LinkedIn. He is advocating, again, a lot of background research and information on Sequela. having, being actually sequelae or multiple effects that have impacted his life and his career. All right, so get in touch with me offline if I've stimulated some discussion and they want to review it in more detail. This is the first webinar. We're going to look at any feedback. So we might send out an email to everybody requesting feedback as well. Yeah, Terry, great information, too much information. Could you target maybe more information on this and your interpretation and your information that's different than what we're hearing from other people? All right, so I'll bring the webinar to a close. I'm just going to look at the Q&A again. I think we're good there. Again, thank you everybody for attending. Appreciate your time today. Get in touch with me again if you need any clarification on what I presented, and we will be sending out some follow-up emails. We'll be sending out to those that attended probably my electrical safety program development implementation checklist, which is really an audit tool if you have an existing program or if you don't have one at all, and what you need to consider. So thank you again, everybody. Appreciate you attending. Have a great day, and we'll end the webinar. Take care. Be safe.